Okay, we're solving rational equations, which sometimes I just call fractions like that. So here are the steps. I'm going to let you pause and walk through them. I'm going to walk through them in the examples. Okay, so here is our example. So start off, check the quadratic factors and see if the other two denominator, or however many there are the factors. So x squared minus 9, x minus 3, x plus 3. Now there are two possible solving techniques, so on those steps I guide you through one of them. If you do this in a different way, you could introduce the extraneous solution, and then you have to deal with it at the end. So I'm going to show you a technique that doesn't do that, and when you get to the end, you actually are going to do a step that eliminates the extraneous without you having to actually think about it. So I like that better. Less thinking, more points. That's edumacation. All right, so we want to set it equal to 0 and combine the fractions with the least common denominator, which is why you need to check that quadratics factors like that. So x squared minus 9 is the least common denominator, and I'm just illustrating in the square brackets, I'm multiplying each of those rational terms by 1. Same thing in numerator denominator, and that's going to get the common denominator, which I will combine into a single fraction. And now I need to pay attention to the numerator, and I need to distribute and make sure I take care of that negative. So I'm going to do it in 2 steps. I think an earlier example I did in 2 steps, distribute the 4x and the 6, and then distribute the negative separately. So you see what I did there. And then in the next step, I'll distribute the negative. And now I'll start combining the like terms. And when you finally get the numerator completely simplified, you want to factor it and see if a factor in the denominator will cancel to simplify the rational function. And sure enough, it does. And as soon as you cancel that x minus 3, I've got a denominator x plus 3, and the process of solving is to get the x out of the denominator. So I'm multiplying now on both sides of the equal sign, and you can see I get 0 equals 6, which is not a true statement. So this is a no solution, provided, like I have cautioned in the past, and my face is in front of that, but always double check on the no solution. Virtually every time a student gives me a no solution to grade, the student has gotten it wrong. And if you think about the test, there's not going to be that many like that. So next example, exact same thing. So I'm getting the common denominator set equal to 0 all at once. Distribute in the numerator, combine like terms. We have a quadratic. Factor the quadratic. At this point, if you distribute the denominator to multiply the 0, you might still end up with an extraneous solution. Factor the numerator and then cancel, if it's possible, something in the denominator, and then move on. So I've factored it, nothing cancels. I'm going to multiply to get rid of the denominator, and I have these 2 factors already, which I do that, and I double check left compared to right. They're both correct solutions.